the Tech Study channel. So, in the previous class, I have explained third important question and its answer of DBMS subject, database management system. And in this class, I will explain fifth important question and its answer. So, fourth important question and its answer, I have explained in the second part. No. So this fourth question and its answer I have explained in the fourth part of the third video. So that is no object based data model. Okay, so in this class I will explain types of attributes and entities with example. So in this class only we will see what is entity and types of entities. In the next class maybe we will discuss about attributes. Okay, and then so here entity. In this class we will see what is entity and types of entities. Okay, so for that we need to understand what is primary key and origin key and also partial key. Okay, so primary key, a primary key is a field in table which uniquely identifies each row or record in a database table. So consider one example. Okay, where we use primary keys and origin keys means here so one department table is there and one employee table is there. Okay, so we are using department ID as a primary key and we are using department ID as a origin key in the employee table. So these two tables are linked with these two keys. Okay, means we are copying this column. Okay, copying this column from first table means department table to second employee table, which is origin key. As a origin key we are copying it. Okay, so origin key can contain redundant values. So here D10 and D10 are written twice, and in this D10 and D20 are written once. So through these primary key and origin key, these two tables are related. Means how they are related means here I have taken this example from many to one relationship. Okay, so in this John and Sarah, two employees, are belongs to only one department, which is D10. Okay, D10 and D10. So here many to one relationship is there, and in the reverse department 10 has John and Sarah employees. So here we have one to many relationship. Okay, like this between two tables we find the relationships. Okay, by using primary key and origin key. So that's the overview of primary key and origin key. So now we will see the definition of it. So a primary key is a field in table which uniquely identifies each row or record in a database table. So here primary key is there. Okay, it identifies each row and each column, each row, only each row in a database uniquely. Okay, because it does not have duplicate values. These are unique values, so that's why it identifies the each row in the table. And then primary keys must contain unique values, means that they are not repeated. Okay, a primary key can't have null values, means empty spaces. Okay, like if it is a primary key, okay, column is there, then we can't leave this cell as empty. Okay, some value is there. Okay, we can't write primary key column as this. Okay, this is not possible. And then a table can have only one primary key. Okay, and which may consist of single or multiple fields. Means in a table it should be only one primary key. That's the one point. And next, it consists of single column or multiple columns. Fields means columns. Okay, so here we have used one column primary key, so we can have a table with two primary keys, two columns as primary keys. Those are called composite keys. So when multiple fields are used as a primary key, they are called composite key. Okay, in a table has a primary key defined on, if a table has primary key defined on any field, then you can't have two records having the same value of that field. Means it should not be redundant like this. Primary key D10, D10, D20. So D10 is repeated twice, so that's why it is not accepted. The primary key should not contain redundant values. And then we should use these concepts using while creating database tables. So database tables are related to each other. Multiple tables are related to each other. So to combine to develop relation between tables, we use these primary keys. And a cluster index automatically created when a primary key is defined. So what is cluster index means? Yeah. So here, clustered index is used to physically sort and store the table's actual data rows. Means like see, so the rows are like this data rows in a column. Okay, these are the rows. And then used to physically sort and store the table's actual data rows present in the table on disk based on that key, means primary key. So a clustered index always sorts the data rows based on the data type of the column. If the primary key values are numbers, okay, 104, 103 and 102 is there, so it will sort in a order like 102, 103, 104. Okay, and if it is a character, means text type, then it will sort in the ascending order from A to Z. Okay, so the numbers examples are sorted numerically 1 2 10 100. Okay, and text strings sorted alphabetically, apple, banana and so on. And data sorted chronologically, 2026 1 1 before 2026 1 2. So if a primary key contains random order of the numbers, then it will change that order to this order. Okay, and if primary key contains text in a random manner, not like this, like banana and apple is there, first banana and next apple is there, then it will sort to apple and banana, like that. Okay, and dates also like that only, first 1 and next 2. So then defining id or attribute as a primary key in customers table. So create table name is customer 1 2 and column name is id and domain is int, not null constraint and primary key. So here we declare the primary key while creating a table. And then name varchar not null, age int not null, address char of 25, salary number 18 comma 2 semicolon. And then creating primary key when table already exists. So using alter command, alter table name is customer, add is a keyword and primary key of id. So id is a column name. Okay, semicolon. Means we are applying primary key on id column. If we use the alter table statement to add a primary key, okay, the primary key columns, means column or columns, should have already been declared to not contain null values when table was first created. So it is saying that when we first create the table, we should declare the column as not null constraint. So after that only we can apply the primary key to that specific column. And then primary key on multiple columns, create table customer 23, table name and id, column name int domain not null semicolon, name varchar of 20 not null, age int not null, address char of 25, salary decimal of 18 comma 2 and primary key of id comma name semicolon. So here id and name, we are combining these columns and making it as a primary key, means as a composite key. So combination of more than one primary key is called composite key. Okay, and when table already exists, how to apply the primary key? So alter table customers, here the table name is customers, add keyword constraint pk dash cust id primary key of id comma name semicolon. Okay, and then drop a primary key constraint, alter table customers drop primary key semicolon, or alter table persons, here persons is a table name, drop keyword constraint pk dash person semicolon, here is the table name, person is a table name. And then so here primary key, so here primary key enforces integrity constraints, not null, unique to the table. Okay, as we have seen in the primary key definition that no null values will be there and unique values should be there, and so it enforces the integrity constraints like not null and unique, which is also similar definition. Not null and unique constraints means not null constraint means a particular column does not have empty values, and unique constraint means a particular column should have unique values, means not repeated values. And then primary key value in a table changes very rarely, so it is chosen with care where the changes can occur in a seldom manner, means which never happens, change never happens. Okay, so example, uh, so if we take student id, okay, student id can be made as a primary key because it can't be changed once it is allotted. Okay, for each person there is a unique student id will be there in a university. Okay, so that can't be changed, so we are saying changes can occur in a seldom manner. Okay, that's why we are saying that. And then a primary key of one table can be referenced by origin key of another table. So I have shown in the table now, in the department table and employee table, origin key, primary key is there, and then origin key is there. So here we are seeing primary key of one table can be referenced by origin key of another table, means these two columns in two different tables are similar, has similar values. Okay, but origin key column can contain redundant data also, can repeat its values. Okay, and then we will go to what is origin key. Okay, a origin key is a key used to link two tables together, as we have seen in the department and employee table example. So this is sometimes also called referencing key, and a origin key column or a combination of columns whose values match a primary key in a different table. Okay. As we have seen in the department table and employee table. And then the relationship between two tables matches the primary key in one of the tables with a foreign key in the second table. Okay. And then if a table has a primary key defined on any fields, they then we can't have two records having same values of that fields. So as I've said, duplicate values are not allowed. And here is the example. Create table. Table name is department 01 and department number column. Column name is department number and domain number of 3 and primary key. It is the primary key and delocation marker of 20. And another other table we are creating. Second table we are creating. Create table EMP01 employee 01 of E number int primary key comma E name varchar of 20 age int D number int references department 01 of D number 0. So as we have already known that referencing key is another name for origin key. So that's why here we are declaring origin key in terms of references. So in the first table, department number is made as a primary key, and in the second table, E number is made as primary key, and department number is made as a reference key, means origin key. Here we write the column name, okay, which is present in the second table, and int domain and references keyword, and then department 01. This is the first table name and bracket of first table column name, okay, means primary column name, which we want to access like a origin key or reference key. And then origin key on alter table. So origin key constraint on the person ID column when the orders table is already created, use the following SQL syntax. So we are using origin key on person's ID column when the order table is already created. Alter table orders, add order table name is orders, add keyword and origin key of person ID in brackets person ID, references persons of person ID semicolon. So here person ID, it's this is the column name which is which will represent in the orders table, and references is a keyword, and then persons is the first table, okay, orders is the second table and persons is the first table, means person is a parent table and orders is a child table. So of person ID semicolon, here is the column name, okay, which is a primary key in the persons table. And then or alter table name is orders, add keyword and constraint keyword and fk dash persons order origin key of person ID references persons of person ID semicolon. fk dash persons order for origin key. Two table names we are giving here, person and order. Then for origin key is a keyword, and then bracket of person ID column which represent in the orders table, and references keyword and persons which is the parent table name, and bracket of person ID which is the column name which is primary key of the parent table. And then dropping a for origin key constraint, alter table orders drop constraint for origin fk dash of person's order. Here orders is a table name, and drop constraint fk dash is a keyword, and person's order means first table and second table name, parent and child table names. And then or alter table orders drop for origin key. Here orders is a table name means child table name, and keyword and keyword. Okay, and then next we have entities. So entities we already know. Entity is a real world thing about which we want to give information about. And then so we have 4 types of entities. Okay, first is strong entity, weak entity, associative entity, and tangible and intangible entity. So first is strong entity. Strong entity, an entity can exist by itself. Okay, exist all by itself. So here entity represents what? Table name, student, that is student. Okay, it has its own unique ID means primary key. Here student is ID is a primary key represented by rectangle. In the ER model we represent it by rectangle. Okay, so we can observe here 101, 102, 103. These are unique values and does not contain any null value, this student ID. And first name and email are there, student details are there. And this table exists even it is not combined to any other table. Okay, because it contains a primary key. So what's the meaning of exist means? So the table can be created, populated, and hold meaningful data as a standalone entity, independent of any parent table, which does not require a parent table. Okay, through which it can access for origin key. So that is not needed for the table, and it has its own unique primary key, and does not require keys from other tables to establish its identity or make sense, because primary key can uniquely identify every single row without needing to reference information from other table. So it does not require a reference. It only uniquely identifies every row. Okay. And then what is, and for example, student exists in the university. Okay, student is an entity. Okay, even if they haven't picked a class, this is another entity, okay, or joined a club at, okay. The student is exist in the university even if they haven't picked a class or joined a club at. So here student entity is not joined to a class entity, so, or club entity in the university, even though they are exist in the university. So this student table in the and coming to this example, this student table exists in the database without what forming a relation with the other table, okay. And then weak entity. A entity can't exist without a parent entity, okay. Parent entity means which contains primary key, and child entity means which contains origin key, okay. It does not have a unique ID of its own, okay, like the primary key, okay, represented by double rectangle, okay, in the ER data model, okay. It contains partial key. So what is partial key? Partial key, an attribute of weak entity that uniquely identifies instances or columns, but only in the context of its related strong entity. Means only if this primary key, this partial key combines with a primary key of the parent table, then it identifies the each row. Means here instances not columns, no, rows are. It uniquely identifies each row in the table only if it combines with the primary key, okay, of the parent table. Means parent table means strong entity table, okay. And a weak entity relies on a strong entity for existence, okay. Means what's the meaning of existence? Means this weak entity table rows can be deleted according to strong entity table. Means it can be deleted, can be created, and the data holds meaningful. Okay, so then so its partial key can't act as a primary key on its own. It's and it is not globally unique. Means the partial key can contain duplicate values. Means D10 D10 D20 D20 like that, okay. So a weak entity's partial key might repeat across the entire database table, okay. Okay, here I have taken partial key. So John and John, they are repeated twice. So here we are saying a weak entity's partial key column might repeat across the entire database table, but it is unique for one specific owner. Means for one specific primary key value as a origin key value. So here are the origin key values, okay, which are taken from employee table primary key. So here it is saying these repeated values or non-repeated values, both, any values which are in the partial key are unique for one specific owner. So here we can observe John has an employee ID 101 and John has an employee ID 102. So they are unique. Okay. We can't write like John and 101. We can't write like that. These values should have unique owners. Okay. John has a unique owner 101 and John has a unique owner 102. Okay. And here unique to employee 101 and unique to Mary is unique to 101 employee 101 and John unique to employee 102 and ABC unique to employee 103. And then John repeats in the database but stays unique to each specific owner. The database allows John to repeat globally, but it blocks employee 101 from having two rows with same name. Okay, with same name means 101 John, we can't write it. Okay, and then while a specific name or number might appear many times in the table, it will never repeat for the same parent record. Parent record, always remember a strong entity record. Okay, and then so here we are saying a specific name or number in this partial key column. Any specific name or column might appear many times. Okay, can be repeated means, and in the table it will never repeat for the same parent table. For the same 101 it can't repeat John and John. Okay, and then here is the example. If multiple employees each name their child John, okay, and the name John repeats across the entire table. Dependent records, it is not globally unique. So if multiple employees each name their child John, the name John repeats across the entire dependent records. So it is not globally unique. Means it is redundant. However, an individual employee can't have two dependents with the exact same name. Means employee 101 can't have two childs with the same name. Okay, so here we are saying an individual employee can't have two dependents with the exact same name. Their dependent name is unique only when attached to a specific employee ID. Okay, with an example I have explained that. Then what is mean by dependent? Means a dependent is in DBMS refers to an attribute or column whose value relies on another attribute. Attribute values known as the dependent. So here we have to write these values according to these values. Okay, John should not be repeated for these two values 101 and 101, this for these two columns. Okay, so that's why it is saying that an attribute whose column values on relies on another attribute. In this case, employee ID, okay, is known as dependent. This relationship is functional dependency and ensures data consistency. Format is determinant to dependent. And then we have another example, that is table, enrollment table, okay. Student ID, contact name, relationship, phone, okay. So here is the two tables are there, okay. Two tables are there. Here first consider only these three columns, okay. Consider these three columns as a weak entity table, okay. It contains primary key, means partial key, pk means partial key, okay, which is contact name, and table name is enrollment, okay. And then it uses a partial key plus origin key from the parent to identify itself, okay. It uses partial key plus origin key from the parent to identify itself, okay. Example, like if ABC of ID 101 leaves the school, means ABC is a name of the student, leaves the school and is deleted, okay. This row is deleted, okay, from the strong entity table, means parent entity table. So her emergency contacts Mary and John are also deleted. So here in the Mary and John, so here we are combining it with the origin key, means primary key of the strong entity table, this table, okay. So that is 101, 101 and 102. So May and John are the emergency contacts of student ID, means the same student, okay. So if the student leaves the school, then these two values also should be deleted, okay. So here, because they have no reason to be there alone, okay, student only leaves, so then we don't need the emergency contacts of that particular student, so we delete these two particular rows from this enrollment table. This is the example of weak entity table, okay, which is enrollment table, okay. Then we have another example. So yeah, there is only one example for weak entity. Then we will go to associative entity. So a helper entity that connects to other entities in a many to many relationship, okay. So a helper entity that connects to other entities in a many to many relationship, represents by rhombus, okay. And we have seen relationship in the ER diagram also represented by rhombus. So what's the relation between relationship and associative entity is? Associative entity is a relationship that acts like an entity Okay, associative entity is a relationship that acts as like an entity. Means here entity is acting, here relationship is acting as a entity, which is called associative entity. We already know relationship definition, that is the number of associations between, means not number of the associations between two entities are called relationships. Relationship. So here I have taken one example, that is enrollment links many students to many courses. Here we have to understand what is many to many relationship of a relational database. Okay, so don't consider this this table and this also. So for a many to many relationship in a relational data model, so that is each row in the first table can relate to multiple rows in the second table, and each row in the second table relates to multiple rows in the first column. That means students and courses, two tables are there, and a student takes many courses, and a course has many students. That's the meaning of this statement. And many records in one table relates to many records in the another table. This is the other definition of many to many relationship in the relational database, in the relational data model. And we can't establish this directly. We must create a third table, often called junction or linking table. So as we have seen in the many to one relationship, we are establishing this relationship as taking primary key of one table, first table, means parent table, to the employee table, means which is child table, as a origin key. So we can establish this many to one relationship. Okay, as I've explained in the starting of this class. So here in the many to many relationship, we can't establish this directly. We must create a third table, often called junction or linking table. So why we need to establish third table means because of data redundancy. Okay, one student can enroll in multiple courses, and one course can have multiple students. We have taken that example, and then this creates a many to many relationship. We can't simply put a list of course IDs in the student table, nor we can put student IDs inside the course table without causing massive data duplication, due to which normalization will be violated. So here we are seeing we can't put course ID in the student table. So if we put the course ID in the course table, then like we have done in the many to one relationship, here we have department ID we have put in the employee table. So we achieved the many to one relationship. But in many to many relationship, we can't put student ID in the course table. Why? Means due to data redundancy. So here S10 and S10 means we S10 student, these two rows belongs to one student only, is taking two courses, C201 and C201. and S102 student is also taking two courses, okay, C201 and C201, C202, okay. And means so each row in this student table relates to multiple rows in the second table, which is two courses. Means a student has joined in two courses, and C201 and C202 has same student, okay. Okay, C202 course, one course, okay. C202 C201 one course is having two students, S101 and S102. So means in the second table we have each row related to multiple rows in the first table. So this forms a many to many relationship. So here we are making severe duplication, means we need many duplicate values like this. So to overcome that we need a third table, okay. So we can't establish this directly, we must create a third table, often called junction or linking table, okay. This table contains the primary keys from both original tables as 4 region keys. From these both tables it will take primary keys and copied it as a 4 region key. This enrollment table is a third table, okay. Then we are creating these two tables, okay. These two tables we are create a table name students bracket of column name is student ID and which is primary key, and student name another column name, and create table courses is a table name and course ID column name, and primary course name another column name. And here we have to write varchar also data type, okay. Here also varchar, okay. And then create table enrollments student ID of 4 region key comma course ID of 4 region key. So here we are taking student ID and 4 region key from these two tables and as a 4 region keys, okay. These two acts as a primary keys for the enrollments table. So A is in maths, A is in CSC also, and B is in maths and C is in CSC. Here one student, A student, is enrolled in multiple courses, and maths course has enrolled by two multiple students, okay, A and B. And noticing how the enrollments table uses the values from the first two tables to create the many to many relationship, okay. Student ID is a unique primary key in the student table as we have seen, and course ID is a unique primary key in the course table, and student ID and course ID are 4 region keys linking back to the tables above, means course table and student table, and together they form a composite primary key. So as I have said, composite key primary key is a key which is the combination of more than one primary key is called composite primary key. This means the combination of both IDs must be unique, preventing a student from enrolling the exact same course twice. So here we have written some important point that is due to the partial key. If in the composite primary key, these two represents the composite primary keys. So each of one is a called partial keys. Okay, means because partial key definition is what it combines with primary key and becomes the becomes the one which who identifies each row in the column. Here composite primary key also does the same. So that's why we are saying that each key in this composite primary key is a partial key. So partial key property is what it is. Its values are filled according to the determinant. For this partial key, this is the determinant, and for this partial key, this is the determinant in this case. Okay, because both are here. Primary keys means in the primary key definition we have studied that owner should be unique for every every partial key value. So here we can see that C201 and C202 C201 and C201 has a unique owners S101 and S102, and C202 and C202 has also unique owners. Okay, that's why we are saying that this means the combination of both IDs must be unique, preventing a student from enrolling the exact same course twice. That's why we are preventing. Okay, due to the partial key property, we are preventing a student from enrolling in the exact same course twice. And then exact same course twice means S101 C201 and S101 and C201. So this student, this S101 student has enrolled in courses twicely, so that's why it is preventing from it. Okay, partial key property. And then multiple students can be enrolled in multiple courses, and multiple courses can be enrolled by multiple students, and origin keys must be duplicated to create a many side. Then so we will see relationship difference between relationship and associative entity. So relationship simply connects two entities. Okay, example, a student takes a course. It describes how entities interact but can't hold its own data, means hold its own attributes, means columns. Okay, like a table. An associative entity created to handle complex many-to-many interactions. It is used when the relationship itself needs to store its own attributes. Okay, we understand it with the example. The student takes a course, and the associative entity is the student and course are two entities, and relationship is takes, and the associative entity is enrollment. Means we can say that the student enrolled in a course. So, an associative entity is enrollment, stores the grade and enrollment date. Okay, so here in the enrollment table we have enrollment related attributes like grade and enrollment date, and these attributes can be dates and quantities and statuses. Okay, so we are discussing about first example now. So here is there. The associative entity allows us to store specific data about the act of enrollment itself. So it allows to store the specific data about the act of enrollment itself, such as the enrollment date and student's grade. How it will looks like means, so here in the many to many relationship enrollment table, here we can observe the enrollment table with enrollment date and final grades or student grades. Okay, so we are adding extra information about these particular students and courses. See, so these values are different because I have taken for different tables, so that these values are different. But we can attach these two columns in this enrollment table. Here we can write enrollment date and final grades. So it will become a associative entity. Okay. Here in this represents only the relationship. Okay, associative entities contains attributes as we have studied in the definition. So it should contain enrollment date and a final grade. Okay, like that it will contain columns. And then we will see so the result. So before understanding the result, we have to understand some points related to association. Here some points are physical database. In a physical database, associative entity is often referred to as a junction table, bridge table or intersection table. It resolves many to many relationship by breaking them into two manageable one to many relationships. So how we will see in the example. So here in the example, the result is student table 1 to enrollment table many and courses table 1 to enrollment table many. This relationship is established. So how means, if we observe here in the student table, S101, S102, S103, these are the unique values. Okay, are there in the student one. And here in the enrollment table we have S101 redundant values are there. in the enrollment table. So here how it forms one-to-many relationship means this particular student is enrolled in multiple courses C201 and C202. So that's why one-to-many relationship is formed. So between student table and enrollment table, one-to-many relationship is established. And if we consider course table, C201 and C202, maths and CSC, course ID and course name are there. So here these are the unique values. Okay, these unique values here in the enrollment table, it is redundant because it is used as a for-region key. So in this a particular course is enrolled by multiple student S101 and S102. So that's why one-to-many relationship is established. Okay, so between course table and enrollment table there is a one-to-many relationship. So here we are saying that there is a student table 1 to enrollment table many, and courses table 1 to enrollment table many, through which severe duplication problem removed and makes retrieving data easy, such as which student are in the computer science course. Okay, and if we consider and then we will see some advantages of the for-region key. So it prevents repetitive data entries by acting as a lookup registry. Lookup registry means it is used to find which product IDs are linked to which order IDs. So I have explained through this example, and it uses those IDs to safely pull the rest of the information from the main tables. Okay, so in the first example we can rewrite this statement as we can use this lookup registry to find which students are linked to which courses, and it uses those student IDs safely to pull the rest of the information from the main tables, which is course table and student tables. And it refers to a central table used to verify, standardize and map relationships between different pieces of data. So, and associative entity makes it easy to enforce referential integrity using for-region keys. So as we all know, we need for-region keys in the associative entity table. That's why it enforces the referential integrity. Referential integrity means using the for-region keys, developing a relation between two tables. Okay, exactly same thing we are doing in this associative entity. Okay, and if we consider second table, this is the second example. Second table orders, two tables are there, orders and products. One order can contain multiple different products, and one product can be sold across multiple different orders. Okay, orders table, student ID, primary key, order date 101, 102, and same dates are there 26, 5, 26, and product table, product ID, primary key, product name and unit price. P50 here, product table, product ID, primary key, product name, unit price, columns are there, and P50, P75, mouse keyword 1200, 4500, and order details, order ID and product ID are for-region keys, and quantity ordered is a attribute of the associative entity, which is order details. and these two origin keys are taken from these two tables, primary keys. So how the one-to-many relationship is established between order table and order details table, and product table and order details table means here we have 101 and 102 unique values. Okay, so this order ID 101 and 101 has two rows, and which is specified to two products. Means one person is buying multiple products, so that's why one to many relationship is developed. And then if we look at the relationship between product and product table and order details table, then P50 is a and P75 are unique values. So here P50 and P50 repeated. So this particular product ID is considered for 101 and 102 order IDs. Means two persons means one product is bought by two persons, multiple persons. So that's why there is a one to many relationship is established between product table and order details table. And by tracking quantity ordered inside the associative entity, the system knows exactly how many units of a specific product belong to a specific order without duplicating product or order records. That means we are not keeping order ID in this table as a origin key, and we are not keeping product ID in this table as a origin key. So if we put that, then we get redundant values. Okay, so that's why we are avoiding that and making a third table. And then these are the two examples of associative entity. So here I have forget to explain primary key example. Okay, what's that means? We take a table named as a student table having attributes such as roll number, name, batch, phone number, citizen ID. This is the student table. Okay, we are making roll number as a primary key. The roll number attribute can never have identical and null values, okay, as we have seen in the definition of primary keys. And because every student enrolled in a university can have roll number, therefore two students can't have same roll number, and each row in a table is uniquely identified with the student's roll number. Okay, so we can make roll number attribute as a primary key in this case. So that's all for today's class. We have seen in all topics regarding entities. Okay, so if you feel this video is helpful, then like, share, subscribe and comment it. And if you have any doubts, ask me in the comment section. I will see you in the next class. Thank you. Bye.